For today's video, we will answer a math challenge given by one of our followers. And the question goes like this. Solve for the integer value of a and b that satisfies this equation 2 raised to a minus 2 raised to b equals 2016. Now you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so our goal here is to solve for the value of a and b that satisfies this equation 2 raised to the power of a minus 2 raised to the power of b equals 2016. Now, to answer this question, of course, one thing to notice here is we have here 2 raised to the power of a minus 2 raised to the power of b must be a positive number, 2016. It follows that a must be greater than b, or this exponent a, or this variable a, must be greater than variable b. And we can now rewrite a in terms of b. So we can say that a must be equal to b plus some number t. So we don't know that t, but we will find the value of t later on. So, we can replace the variable a with b plus t. If we do that, we look something like 2 raised to the power of b plus t minus 2 raised to b equals 2016. Now, let's focus on this equation and don't forget that a must be equal to b plus t. Alright, now let's solve this equation. To answer this, we will use some laws of exponent. If we have x raised to the power of y plus z, this can be written as x raised to the power of y times x raised to the power of z. Therefore, this term right over here can be written as 2 raised to the power of b times 2 raised to the power of t. Now, notice that we have a common factor of 2 raised to the power of b, so we can factor out 2 raised to the power of b. If we do that, we get 2 raised to the power of b multiply by 2 raised to the power of t minus 1. And again, if we distribute 2 raised to the power of b in these two terms, we go back to our previous result, which is 2 raised to b times 2 raised to t minus 2 raised to the power of b. So let's have the factored form. Alright. Now, what we're going to do is to factor out 2016. And in order to do that, you can use factor 3 or divisibility rule. And if you do that, you get 2016 as 2 raised to the power of 5 multiplied by 3 raised to the power of 2 multiplied by 7. Now, we will replace 2016 with its factored form. Now, why is this important? Because the left-hand side of our equation, notice that 2 raised to the power of b must be always an even number. 2 raised to some power is always an even, and 2 raised to t, an even, minus 1 will result to an odd number. So now, notice on the right hand side, 2 raised to the power of 5 must be always an even number. But this 3 squared, or simply equal to 9, 9 times 7 must be equal to 63, which is an odd number. So, we can say, since we're dealing with an integer value of a and b, so we can say that 2 raised to the power of b must be equal to 2 raised to the power of 5, and 2 raised to the power of t minus 1 must be equal to 63. So, we can rewrite this as follows. We have 2 raised to the power of b equals 2 raised to the power of 5. And another equation, we have 2 raised to t minus 1 equals 63. Now, let's focus on the first equation that we got. 2 raised to the power of b equals 2 raised to the power of 5. We have two expressions that is equal. We have the same base of 2. Therefore, we can say that their exponent must be equal. So, b must be equal to 5. Now, we found the value of b. How about the value of t? Let's add 1 on both sides. Now, 63 plus 1, this will give us 64. And 64 must be equal to 2 raised to the power of 6. Now, we have the same expression on both sides. We have the same base. Therefore, their exponent must be the same. So, t must be equal to 6. But don't forget that we don't want the value of t, we want the value of a. And we know that the value of a must be equal to b plus t. Now we know that b must be equal to 5. And this t, we found this is equal to 6. So a must be equal to 5 plus 6, and 5 plus 6 must be equal to 11. And that is the values of a and b that satisfies this equation. 2 raised to the power of a minus 2 raised to the power of b equals 2016. And as always, we are done.